Let's get going on example 3. So again, before I get started, I like to label the different parts of the triangle, which I have a 30-degree angle and a 90-degree angle. So what do you guys think is the missing angle? Holy hot dog, that would be the 60-degree angle. Okay, so the short leg is the side directly across from the 30-degree angle, which in this case is the X. The long leg is the side directly across from the 60-degree angle, and the hypotenuse is the side directly across from the right angle, or the 90-degree angle. Okay, which the side I was given in this problem is the 5, which is the long leg. So I'm going to use the long leg ratio 2 times to help me solve for x and y. And the long leg ratio is root 3 over long leg. So it's going to be root 3 over the long leg, which is 5. Okay, and let's set up these proportions so we can start cross multiplying. All right, and then on this one, x is the short leg. The short leg ratio is 1 over short leg, which this happens to be the x. So it'd be 1 over x. All right, and on this side, the y is the hypotenuse. The hypotenuse ratio is 2 over the hypotenuse, which happens to be y. So 2 over y. All right, from here, I'm just going to cross multiply. So let's do it. All right, root 3 times x. Well, I cannot multiply those together, so it's root 3x. And that will equal 5 times 1, which is 5. All right, so now I need to solve for x. Currently, the root 3 and the x are secretly multiplying together. So the way I'm going to move root 3 to the other side is by dividing that bad boy on both sides. All right, root 3 divided by root 3 will cancel and turn to 1. So I'm left with x equals 5 over root 3. But don't forget, we do not like to leave square roots in the denominator because then our answer is not in its most simplified form. So if you remember, the way that we undo a square root, the opposite or the inverse of a square root, is to square it. So if I multiply a square root to itself, kind of like what we did over here, the square root and the squared will cancel out, and we won't be left with a radical anymore, which we're not trying to end up with a radical in the denominator. So let's get started on that. So I'm going to multiply, I'm going to rationalize the denominator and multiply the numerator and denominator by the square root in the denominator. Okay, I'm going to multiply straight across. 5 times root 3 is 5 root 3. And root 3 times root 3 is simply 3. Just like up here, root 3 squared, the square root and the squared cancel each other out, and you're left with the number on the inside. So anytime you square or multiply a square root to itself, you end up with the number under the radical, which is called the radicand. So root 3 times root 3 is 3. All right, so finally, x is going to be 5 root 3 over 3, which I know looks really strange, but that's okay. We're good with strange. So x is 5 root 3 over 3. All right, I'm going to do the same thing with y. So root 3 times y is root 3y, and that'll equal 5 times 2, which is 10. All right, I need to solve for y, which currently the root 3 is secretly multiplying to the y. So the way that you move root 3 to the other side is by dividing it on both sides. Okay, the root 3 and the root 3 will cancel out and turn to 1. So we're left with y equals 10 over root 3. But holy hot dog, you guys, we can't have a radical in the denominator. So we need to rationalize the denominator by multiplying the radical to the numerator in the denominator. So I'm going to multiply the root 3 to the numerator and the denominator. All right, which I'm going to go straight across. 10 times root 3 is 10 root 3. And a radical multiplied to itself equals the number on the inside, or the radicand, so it would just be 3. Or you could do root 3 times root 3 is root 9, and the square root of 9 is 3. All right, so for our final answer, we get y equals 10 root 3 over 3, which again, I know that looks a little strange, but we are cool with being strange. So look at that, you guys. Nice work, everyone. Toodles.